Hello, my name is Björn Brems. I'm a neurobiologist and I work at the Free University of Berlin in Germany. Today I'm going to show you how we prepare fruit flies Drosophila to learn colors or patterns or their own behavior or any combination of the three. Fruit flies may be able to learn, but they're probably not as smart as other animals, so we need to be really nice to them and treat them well. Two of the most important factors considering fruit fly learning is their age and their diet. Now I'll show you our special fly breeding regime. So in order to stage the flies, we have to put new flies on new food every single day. So those are here now 10 days of flies, with the youngest flies that are just being deposited as eggs in the first vial, and the oldest just newly hatched flies in the last vial. The first thing you do is that you remove all the flies that have hatched from the vials. In this way, there are no more flies in this set of vials, and tomorrow every new fly that you have in there will be exactly between 0 and 24 hours old. So this is how we control the age of our flies. Now we need to control for the density of the fly so that every fly gets a sufficient supply of food. In order to do this, we first discard the flies that have been laying eggs overnight. And prepare a new vial with 4-day-old flies that contain roughly approximately 20 female flies. This is the density at which this particular strain at least produces enough but not too many offspring, so that there won't be too much competition for food in the vial, and the progeny of these flies will learn fine. First, we need a way of attaching the flies to our measuring device, the torque meter. For that, we glue the flies to little triangular copper hooks and then use a clamp to grab a hold of those hooks that we put into the torque meter. And this is how we make those hooks. We just wrap a copper thread, a copper wire, around a little triangular tool, and then we just cut one side of the wire, and what will fall out at the end are little copper hooks, as you can see. Now we pick one of those hooks and then place it in a clamp which is attached to micromanipulators. We put some glue at the very tip of the hook, right here, just a little bit. And then we place the hook in the clamp right under the stereo microscope. So we try to isolate as few female flies as possible. We use female flies because they are larger than male flies, not because of a sex bias. Male flies learn just as well as female flies. And we cold anesthetize them also as short as possible. So as light as an anesthesia as possible, as light as an anesthesia as possible, and for as short an amount of time as possible. We position a female fly under the hook and discard the remaining flies. In order for the fly to remain still and with the dorsal side up, we slightly weight the fly until it is perfectly aligned. And then we position the hook using the micromanipulators exactly on top of the fly, right between head and thorax. Now we lower the hook until the drop of glue makes contact with the fly. And then we quickly cure the glue using the UV lamp. And to minimize the time under cold anesthesia, we lift it from the cold bed straight away. A few more seconds of curing, and the fly should be awakening. And if we now blow the fly, we will see that it is flying. Very nice. So we take the fly and put it into a small container containing filter paper and sucrose, few grains of sucrose. In order for the flies to be able to survive the night, we have to provide them with water. And for this, we cover the vial, place it in the center of the flywheel, and open it just a little bit. And now they have filter paper that is moist and sucrose, so they have food and water for the night, so that they are ready for the experiment tomorrow. Behind me you see the setup that we use for our experiments. The core piece is the torque compensator that you can see here, the cylindrical object, and we'll put the fly later right down here. Underneath the compensator you see what we use to generate an environment for the fly. It's composed of this black box with an arena inside it, and the black box is surrounded by light guides which transmit light from the light source here to illuminate the arena from behind. The data that we acquire with the torque compensator goes via a few electronics into the computer where it is stored. Besides storing the data from the behavior of the fly, the computer is controlling a variety of other instruments. One of them is, for example, here a set of filters with which we can dye the environment of the fly either green or blue, for instance. Another device is an electric motor which turns the arena, as you can see here, so that the fly gets the impression that it is actually flying in a sort of flight simulator situation. You can do this, for example, with different visual patterns such as these upright and inverted T's. A third device is a laser, which is situated here. It's an infrared, fairly weak laser, which we can use to heat the fly, which is an aversive stimulus. Okay, so here are the flies. Now let's just pick one. Pick it by the hook. And then get the clamp. Place the fly as symmetrically as possible in the clamp so that it is central and that the body angle of the fly is around 30 to 40 degrees. Just make sure that everything is working correctly. Of course, usually the lights will be out in this room and it will be dark so that there will be no distracting stimuli for the fly. But for this demonstration, we will leave this away so you can see the details of the experiment. Now we lower the fly into the environment, into the arena. Open the security latch. So now what we have to do is we have to adjust the yaw torque of the fly. It is impossible to place it exactly in the middle of the measuring device so that straight flight for the fly is also straight flight in our measuring device. In order to compensate for this problem, we will turn the arena around the fly at a certain speed to elicit a turning movement, an optomotor response, and make this maximal optomotor response, left and right turning, zero symmetrical, so that exactly the middle between those two maximum optomotor responses will correspond to straight ahead flying. So the last remaining task before we can start our experiment is to adjust the punishment, the laser that we use to heat the flies. For this, I use a little piece of infrared filter that filters just enough heat so that the fly doesn't really feel a lot of it, but I can still see it on my monitor here. So I have a little camera, an infrared camera that monitors the fly and that I can use to adjust the laser until it is focused on the head of the fly. And then, because we have a striped cylinder in here for the optomotor response, we replace this with our arena of choice, in this case an empty arena that just leads to a completely white environment for the fly. You can see that the environment for the fly is completely white. There is no other stimulation. There is basically, since it is very close, there is no olfactory stimulation. There is very little other stimulation that the fly could perceive. It's flying stationarily. Nothing is really changing in the environment of the fly, yet still it is producing very variable behavior that ranges from left turning to right turning, and variability within those two domains as well. Okay, and now I'm going to show you the versatility of this setup and how you can use it to train the flies once they're in the simulator. One of the things you can do is simply, now that the flies have this empty white arena, now you can say, okay, whenever you turn right, we will heat you. This is something we can set up very easily. As you have seen, positive yaw torque means heat on, negative yaw torque, for example, means heat off. In addition, what we can do, we can help the flies by showing them what is right and what is left by coloring the arena in green or blue when they turn right or left. So this is what we're doing here now. So now the fly is producing right turning yaw torque. As you have seen, the color changed from green to blue, but now it's turning back. So now you see fly is producing yaw torque in the, in this case, unpunished right turning domain, and as soon as it dips into the punished domain, the heat comes on and the fly very quickly moves away from the heat. As you can see, it modulates its yaw torque very quickly to get out of the heat as soon as it notices it's becoming hot. At the same time, it will still try to produce behavior in the full range of motion, which we prevent by heating the fly. So this is roughly how you can teach the flies to learn either colors or their behavior, their left-right turning, or both together. More traditionally, though, this setup has been used for about 15-20 years now to teach the flies to distinguish between different visual patterns. We can do this very easily. We just take the color filter out. We stop this program and replace the arena. That was blank before. Now, with this arena with upright and inverted T's. And then we have to change the program and start the program for this pattern learning. What you can see now is that the fly, which is the trace here in the middle, is controlling, that is the second trace, is controlling the position of the arena. In these histograms that you see here, you see the amount of time that the fly is spending fly towards the 4 different patterns. So in green you see the patterns that will later be heated, and in yellow the patterns that are not punished. So in this phase now we have switched on the punishment, and whenever this trace here, now that is green, is in the upper and lower or in the central area, the fly is heated. So what you see is that the fly, as soon as it gets into those areas, it moves away from them. So it changes flight direction away from the heat. You can also see this again in the histograms, where now the punished T's are shown here, and that as soon as the fly goes in here, it gets punished and quickly moves away from the heat. It tries every once in a while to move towards the other pattern, but very quickly moves towards the unheated pattern. This is the traditional way in which, in the 1990s, people have started to condition flies, and this is the tradition that I'm in. The entire setup was not developed by me, in part by me, but most of this design originated in the 1960s in Göttingen with Karl Götz, then moved to Würzburg in the lab of Martin Heisenberg and Reinhard Wolf. Those 2 people in particular were the ones behind the development of pattern learning in this flight simulator situation that you just saw. I did my PhD with Martin Heisenberg in Würzburg, and he was so kind to loan me this setup for my experiments here in Berlin.